How far is it?
About fine.
Should I scrub it on here?
10.
It kinda looks like it's coming out.
It's okay.
Oh, my nose been giving me.
It's okay. This one goes there?
Feels like it's coming
Oh,
out.
this one or that one?
This one goes there.
Not this one too much. I feel like the left one. Well, now yeah, kind of
It's like sliding. Oh, see?
dropped it.
Oh, yeah.
Not stuck.
It's just a little round up
It's
in
like-
the
yeah,
right?
exactly. But it's like
Oh,
sliding
never mind.
down.
I'm sorry.
The insurance is fine. I can.
It's this one.
Yes, I got 3. That's fine.
Am I in the? Where is this thing? Am I in
Oh,
here?
you're good.
So what is the steady component? The new, so what is what is the full form of ASSR? What is ASSR?
Steady state response.
So auditory steady state responses. So what is steadying the new generation Eclipse? Like new generation ASSR implemented in this Eclipse system? Huh? So it's a steady state response. Some aspect of the stimulus has to be steady,
The rate.
so that the response for that steady component is looked at.
Is it the rate?
Yeah, the repetition rate.
Okay.
So that's kept constant for that particular frequency. The response is looked at that repetition rate and its integral multiples. So in the Eclipse system, it looks up to 12 harmonics. It performs both amplitude as well as phase analysis. When the time domain continuous EEG is converted into it's broken down into small chunks, probably 50 millisecond, 100 millisecond chunks, and then they're converted into frequency domain. And you look at the response in frequency domain. For each frequency, you will have the response amplitude as well as the phase. So the Eclipse system implements both amplitude at the repetition rate and its harmonics, as well as phase analysis. Okay. So the CDJ is a little noisy. So most of the things you don't have much control here. It's starting at 50 dB, assumptions that you might have normal hearing. So this is a correction factor. It has built-in correction factor for 90 Hz sleeping, 90 Hz child, and adult 40 Hz. Okay. And the stimulus rate is 90 Hz. You got 3 rates: child 90 Hz, adult sleeping 90 Hz, adult awake 40 Hz. You're playing with inserts, and the rejection level is set at 40 microvolt. You're playing all 4 frequencies simultaneously. And this is the speed and accuracy. Speed is 95% response confidence. Accuracy it looks for even more accurate response of 99%. Good speed. That's it, just start.
Can I ask a question? Can you remind me again why the stimulus rate is slower for awake?
Oh,
Awake.
that's weird.
So the question is why the stimulus rate is because when you're awake. Before that, we discussed in the last class about how the amplitude changes with the modulation rate or modulation frequency or the repetition rate. We saw that the amplitude was bigger at 40 Hz, then it went down. So the advantage of using 40 Hz is you get larger responses, lesser test time, lesser number of sleeps and all that, and close to the behavioral threshold. But historically it's believe that it's affected by sleep. So when somebody's awake, then, yeah, one of you can use the computer. What about Melissa?
Sure.
So, I think it's already reaching the threshold. You can right click and select 30 dB. So that's why it says adult awake at 40 hertz. Again, it's still, yeah, you can do it for all frequencies.
Just individually,
Yeah, you have to do it individually.
30?
So that's what you're gonna do in your lab when it reaches 50.
So for lab, I have to do it at 50, 30, 20, 10, and 0.
I think that's what is in the protocol.
Mm-hmm.
So you can still do like at 4000 hertz, you can right click and have 30.
Are
10
they
is
all
like
running?
waiting.
They're all
Yeah.
running at the same time?
Yeah,
Okay.
yeah. So because by the time you change it reaches the response, so you have to do it again.
Yes, these stuff is stimulus sound weird.
What's it?
They sound weird.
Yeah, it sounds really loud and weird.
Mhm.
Like frog, what do you call it? What is the? So, say right side already reached. So
We'll go down to,
yeah, 20. You can keep it waiting also. Yeah, you can go. Thousand hertz also you can have it. So pen is like waiting, right? Pen is the meaning, yeah.
So once it turns green, it'll go to the next
Next one, yeah. You can have 10 dB also for the remaining ones. The problem is if it doesn't reach, then you have to cancel it. You can see the range of intensity it provides. It's based on the highest intensity what is played in that year, it gives plus or minus 20. $2,000 hertz one more time, I can press it.
It'll take like a second to show.
Now, by the time your show is clicking, it already reached. So if you can, you can be slow because if you once one of the setting implementation is waiting, we go on click on the other one. Sometimes it freezes.
Mm.
So I think they have fixed those issues, but still.
And also do it at 0, right? When
Yeah.
it reaches 10.
Yeah, you can go to 0 if it allows. Yeah, 0.
Oh.
Start new intensity.
Oh.
Yeah. Oh yeah, it's a really good threshold. So at 500 hertz is very rare that it goes below 10 and all. So at 2K, 4K you can have it. Because if there is no response at 10, then there is no point of doing at 0. So you can go up to 15. So it's only 5 minutes. Right side, you already know that it's normal hearing. I think applying correction factor, we already know it's normal hearing. If you can click on that audiogram tab on the left. See, it's applying correction factor, it's all normal hearing. So 5 minutes you're
I have
done.
a noise notch.
Still normal.
how long do you let it run for before you decide, okay, it's not gonna, like,
6 minutes, the default is 6 minutes.
for 5K, like, if you don't get a response at 10, at what
500
point?
hertz at 6 minutes.
Or 500, sorry.
If we have no response at 10, do you want us to also run 5?
I think in the lab protocol I did not include 5. If you want to be 5 dB accurate, you can do it as well.
So you would let 500 run till 6 minutes and then do 15?
Yeah.
Okay.
Again, it depends. Now it's at the higher end, so you can develop your own kind of protocol, what level, how to choose, like when to stop, when to raise, all that. But the default protocol is 6 minutes. It goes to 6 minutes. One of you can do a study comparing what is the threshold if you use 2 minutes, 4 minutes, 6 minutes. Is there any value of 4 minutes to 6 minutes and all that? Just compare the threshold across 3 conditions.
So it's been 8 minutes. Do we keep running it?
Each recording is 6 minutes. It's not the total test time.
Oh, I see. Okay.
I think there was one research study which showed I think 28 minutes or 24 minutes, I don't remember. On average it took 24 or 28 minutes to test an infant.
That seems like a long time, doesn't it?
That looks
24
like-
minutes?
It's pretty long.
I thought this was supposed to be faster.
Well, compared to APR, it is so much faster. I think the EEG level is quiet. It all depends on the EEG. If somebody has really low EEG.
I think that might be a good study, because like what would be the point of going all the way to 6 minutes
Yeah.
if 4 minutes is
4 minutes is enough. Generally, you can also look at what percentage it was. Like if it was more than 75 at 4, how many of them reached 6, like
Mhm.
100%, all that, so. Because it's going at fast rate chirp, each second has like 90 chirp on average. If it 90 per minute is 90 times 60, which is how much, 5400. 2 minutes is like already 10,000 sleeps, 10,000 chirp per that frequency.
If you did that study though, like on normal hearers,
Yeah.
would that matter? Like would it change for someone with a hearing loss?
Yeah, plus I think it's, with hearing loss you got those recruitment thing and all,
Mm-hmm.
so. You can look at the hearing impairment also. So, again, you're looking at what is the threshold using 2 minute.
Mm-hmm.
2 minutes, if it did not reach like 95%, then you increase it.
So if results are within normal limits at 10, do you still have to do up to 0 or 5?
For the lab you can do it, otherwise you don't do it. That's-
Mhm.
So let's do, probably it's, you can, if you,
Alright.
yeah, you can run 5 and. You can,
5.
yeah. You can click the bottom one, it will start immediately. No, when you right click,
If you right click at 4K in the left, you'll see it.
so right click,
This one?
yeah.
Mhm. Go to
5. The bottom one there, it will
Start
start
immediate.
immediately. So you set 15, I think, on the top. Left 500 hertz. Sets 5.
Do 5.
Yeah.
And then we do 0 for 1K on the left.
Can do that. Yeah, you can do 5 or 0. You got really good response. I mean, lower, probably might have really good thresholds. Really, you don't get like below like those 10 dB response for 500 hertz, especially like for male participants. So you got an idea about this. So now we'll go to bone conduction. So you can stop it. So for your lab, you're not gonna, if you go on the audiogram tab there, audiogram, you're comparing the ASSR threshold with the behavioral threshold, not the corrected one. There if you see AAA,
Mm-hmm.
that's the ASSR threshold. That threshold you're comparing with the behavioral threshold.
Which is
So-
the estimated? Or the behavioral, are we asking the patient? Oh. Oh, we're also doing
The both, yeah.
the both, okay.
Because that's why you're trying to get information about what is the behavioral threshold. So when you can obtain person, when you can obtain that information on a person, that will give you information about, okay, how does it compare to. But across the class, you can just average. I'll just average it and give you the number.
But that should line up to.
Yeah, that should line up because I think probably that study that 30 people in your class and only 14 should be very close. Okay. Okay, we'll do bone conduction. You can save and exit and start it.
How do we do bone, do you know?
I guess with the bone oscillator.
Yeah, just press the bone oscillator and then.
Just
Yeah.
leave this,
That's fine.
leave the same
Yeah.
setup on?
So that's the ASSR module you have to select. Okay. And you select stimulus as bone conduction. Again, you can choose mask, insert your phone and all that. If you want to choose masking level, just try to select the level plus 30. Okay,
This right here.
so that is a correction factor. The stimulus rate is 90 Hz, adult sleeping,
Mm-hmm.
then bone conduction is bone mask inside your phone. You selected the right one. Yeah. Ejection rate is 90 microvolt. 40 microvolt. That's good. Then yeah, you select you're gonna place which year you want to place.
Right.
And this is not part of the lab. We're just
Oh.
doing it in the.
We have to do both for one.
If you do it, you get 2 bonus points. I
Oh.
think that's what I told the last group.
Wait, really?
Okay, so we put the,
One, yeah.
for
Okay.
both years?
Yeah.
1 year is. Can't do both here. Only one bonus later.
Okay, which, left, right?
You can pick.
Yeah, I'll check.
No, but I'm saying to get the bonus, but you want us to do it, you want us to do both for the bonus?
Yes, I think
No,
it's-
just one.
Okay.
You can take your hat off.
Oh, yeah,
So we're doing behavioral thresholds in the booth and then coming here, doing air and then bone for,
Yeah, that
It's
way you can do,
repetitive.
or you can do from here and then go there.
okay.
Because that's what you're trying to do with ABR ASS and all, you're trying to
I
get
leave
clean
the
audiograms.
inserts in,
You can take it out. Or you can take out the left one.
the left.
So we're gonna play, do you wanna play some noise?
Yeah.
So we can start at, let's start at 30 because 50 will, let's play at 50, it may be too loud for him. So
And then,
that's the left, right?
then the right
and
we
the-
put masking.
Yeah, you have only white noise. See, in the audiometer, the noise is calibrated at effective masking level. That means if you're playing a tone at 70, if you play effective masking noise at 70, that kind of mask out that. That's like the threshold.
Mhm.
So whereas here, it's not that complicated, it's just white noise. White noise has equal energy across all the frequencies, it's not an effective masker because it has all the energy and it sounds loud.
But that's just because you're covering all the frequencies.
It doesn't have a lot of options.
Yeah.
In ABR also, you only have white noise.
You said it's not an effective masker?
Yeah, white noise is not an effective masker. Then you have to select,
Okay, then, whatever, yeah, on that one,
and select,
the decibel level.
so you play noise plus 30 dB. I think we discussed about bone connection masking with the last semester with the ABRs. You play 30 dB higher than the test tone for the ABR. That is
Higher than
30
the test.
30 dB higher. Yes, but
That's crazy.
you can go at 40. I want to show, don't play any noise now. I want to show you some artifact problem with the bone
Okay,
connection.
okay.
Just select all the frequencies, just put it off. Select, you can't even play 500 right, no, you can't even, not that one, the bottom one. That's the left, 500 can you select?
No, that's grayed out.
No.
So you see, because of the artifact issues, they don't even let you play 500 hertz here. So 50 dB gonna be too loud. Let's see some artifact problems, okay? It's just okay. Let's see, you're gonna scream, I think. Let's see.
We keep the
Scary.
inserts in,
I took
It's
the
a
left
good
one out.
we keep the right.
Okay, press start.
See, I did a little student project. Even if you put insert in one ear or other ear, the occlusion effect is the same. So it's one ear or both ears,
Mhm.
it doesn't change the amount of occlusion effect. We thought of doing one project, then one of the guy would measure some bone connection, he told it doesn't change, and we did some real ear measurement, put the probe line to probe, it's the same.
Start.
Yeah.
So it's all getting rejected, you can see.
Yeah.
So that's the problem with bone connection ASSR. There's a lot of artifact issues. In the EEG you can see, what do you see on the EEG? Can you point to the
It's
EEG?
noisy.
It's noisy, it's okay, on
You
the
can
right,
see
on the
the
left.
stimulus.
On the left.
You can see the stimulus, that's the
Oh.
stimulus.
Yeah.
And that's just because what, the intensity level?
And then
Yeah,
the
the electrode is picking up the stimulus being played. That's why the chirp, narrowband C chirp are presented in alternating polarity so that to cancel out the stimulus.
But what if you played at a lower intensity, will you
Yeah, you
still
can't-
pick that up?
You can let's see that, so 50 did not work out, you can't even play 50. It's all, everything is getting rejected. So now go to 40.
So if we already have their air conduction ASSR and their audiogram, do we have to run bone at that level or should we just do at 10 or 15 where like we know
Yeah,
it's
you
gonna
can start
be
at 30. I just wanted to show you 50, that's why. We would have started at 30. So this is 30, it's done by. I still see that, but probably because it's alternating polarity, the stimulus artifacts will get cancelled. Rarefaction compensation, rarefaction compensation across all the frequency, hopefully it get cancelled. it already reached, you can decrease it. See, you could hear, see the sound is being played in bone conduction, you can hear that. Why is it? Even in your testing, you might have seen, you may be testing in the outside, you're testing 2K, 4K, like when you play 50, 60 dB, you can hear through the microphone headset.
It's
Why is it?
vibrating, it's how it gets
It's
moving.
vibration.
Yeah, vibration.
Even 500 hertz it will move,
Mm.
but you don't hear it.
Mm.
Is it cause it's all of the frequencies?
So because of because of acoustic radiation, like high frequency, it'll, because of the bone conduction,
It like bounces off the head.
some of the sound gets leaked out into air connection, like in the
With
air.
high
Mostly
frequencies?
high frequencies. So that's why when, see now,
Mhm.
when the 30 reaches, it'll stop. So that is called acoustic radiation. In the past, people thought, oh, what if the sound leaks and goes through the air condition, patient hears? Is that a problem?
No, because it's not based on their response.
Huh?
No, because it's not based on their verbal response or their reaction to it.
I mean, I think it
No,
would be a
because
problem
their air
it would
couldn't be
respond,
better than their
right?
bone.
Yeah, you are correct.
Yeah, their air couldn't be better than their bone.
Yeah.
So if, imagine you're playing bone connection at 50, there's some sound leaked out. If it goes through air connection, the patient has poorer air connection
Mhm.
than bone connection, so it should not be a problem.
But the patient's not even responding. Are you talking about ASSR
No,
or
in general.
behavioral? Oh, okay.
Like when you play 40 dB, like say 60 dB at 4000 hertz, when you play it, if you have the headset on, you can hear it. That's
Yeah.
because the sound is getting leaked out in the air connection. I don't know whether they have measured how much is it actually leaked out energy. There's acoustic radiation, how much it is, what is the level of it. You can
At
put a
like
mic
each frequency?
at frequencies. 500 hertz you may not hear it, but 4000 hertz you can put a microphone at the ear level and see what is the energy. So maybe just curious, just what is the SPL at the ear canal.
Of the opposite ear, that's what you're saying?
Opposite or test ear, both ears. If they hear any ear, it'll help you both ear.
Just to see how much is leaking out or
Yeah.
how much goes to the other ear?
Yeah, test ear also, test. I don't know how much it could be. It sounds loud, right?
Mhm.
Yeah. If you play like bone connection 70 dB, it can go low.
To which one?
Yeah, 10 there is a response, right? You go down.
But normally if we close the gap, we don't have to do beyond 10, right?
Yeah, it's already normal hearing. If it
Yeah.
already has audiogram, you can go and check. It doesn't have normative data, so that's why it's plotting those actual thresholds. Yeah, bone connection SSR up to 45, I think 50 was a problem. 40 we were able to do. I think after this try 45, see what happens. And if you go beyond 55, the equipment will not allow you to play all frequency at the same time. It will tell you to play only one at a time.
If you go beyond what?
55 dB bone connection.
Stop and do 45?
Yeah,
Wait
I can,
for this.
yeah.
And that's just because it would pick up.
Yeah, there's interference in the neighboring frequencies.
Oh.
There's not much research done. I don't know how they probably just acoustic output measurement and seeing.
And that's because of the proximity of the bone to the electrode?
Proximity of the frequency.
But how come it doesn't do that for air conduction?
The air conduction,
Like why are you able to play it,
Louder.
yeah, with air conduction? It doesn't interfere.
Yeah, that's a good question. With the bone conduction, more than 55, it doesn't allow you to record.
Mm-hmm.
Probably because of the artifact issues. Again, 50 itself we couldn't record.
Yeah.
Probably
Because it picks up the stimulus.
because it picks up the stimulus artifact. So probably that may be the reason.
Oh, why?
The electrode is closed. You could.
Oh, so that's what,
Yeah.
that's what I asked, okay.
Yeah. So because and also even with air connection, you're playing the sound here. Electrode could be here, but here the bone oscillator is driven at very high voltage.
Mm-hmm.
It's driving the bone, so there's high voltage changes going on. So
Mm-hmm.
that has been picked up. Even with air connection, it's a problem at like 90. So that's why one of you can do a project looking at 10 deaf individuals, do high intensity air connection, high intensity bone connections to see what are the problems.
You're really trying to get us with this big project, huh?
I got 4 students and
You
need to
did?
go.
Oh, did you get any yet?
I don't know what, I don't know,
I don't know if Dr. Sonia will.
I don't know, if you want it, that's it. It's your project.
I want to
Huh?
because it's easier than EEG.
Yeah, so then you tell me that's it, that's it.
Don't be scared.
I'll protect you.
We'll see.
So one you can do 2 minute, 4 minute, 6 minute, that's good. The other project could be, this is a new generation SSR.
Oh, interesting.
We also got old generation with the amplitude modulation.
So like compare that.
Compare them, that's,
I
and
like
then,
that one about the deaf,
Huh?
that's interesting, the
I
deaf
think it would
individual.
be a good one, yeah.
I think if you get like contact deaf community, if generally they would know
I
what to
contacted the professor that did like a guest speaker, because he said he was
Oh,
gonna do
yeah.
ASL club, but they haven't started it.
Mhm.
We have a couple of, at least 2-3 ASL lecturers, 3.
Mm-hmm.
I know at least 3. One he has some hearing, other 2 they don't have any hearing. We can get 10, 12 people over 6 months, and this is an exploratory. We don't know, just measure, see what can you do,
Mm-hmm.
whether it's reliable. I think there are comparable studies with the old generation. Let us see what they have done. I just try to mimic that.
I mean, I think it's interesting, they don't really have a lot of data on this new equipment.
So 3 projects will be this. You can pick. I need to come up with one more.
Mm-hmm.
Again, even though you see that stimulus artifact in the EEG, it would get cancelled out because it's using alternating polarity. So even in air conduction and bone conduction, it's using alternating polarity.
So this wouldn't be good for diagnosing like a mixed loss?
Yeah, even the ABR is not very good.
Mm-hmm.
You just get what you do with like ABR, you do air conduction, and if it's like severe to profound, then you do bone conduction to the highest level. If you don't see a response, then it's censored in your own. But mostly, like if there is no known condition, then what you're suspecting is like you got emittance to tell whether there's any conductive mixed. Okay, I think we can do 45 and see, and do some single frequency. It's okay, we're just gonna see whether we'll be start. See now you go to 4000 Hz and stop it. Right click stop. Okay. See mostly the radiation happens at 4,000 hertz, high frequency.
Mm.
Yeah, you can look at in the ear canal. What is the BBSPL reaching the ear canal at different intensities? Is it linear
At the
growth?
test tube?
Test ear, not test ear.
Oh.
It doesn't matter. But yeah, you can do both.
Mm-hmm. But what would you use to,
Put a probe microphone in the ear canal.
yeah.
Yeah, put like portable audiometer. Put the probe microphone in the ear canal and see what is the level. That's it. It's a too small project. We did that. One student wanted to do the occlusion effect, right? Like 1 year, 2 year.
Mm-hmm.
It was actually the same. Whether you occlude 1 year or other year, the bone correction threshold was the same. And there's some evidence on that also.
Mm-hmm.
Okay.
So 45, I think you're able to do it. It's recording? Oh, it already reached, right?
Mm-hmm.
Yeah.
Okay. So what about 50? Let's see. Earlier we couldn't record it.
If you turn on 4K.
It'll start. I think, was it on? Go to
It's on,
setup.
Yeah, go to setup.
Yeah, 4K
Turn
is
off
on.
the 4K.
It can be there.
Leave it there?
Yeah. Then we'll do single frequency. So again, 50 dB NHL, that's like probably 75, 80 dB peak equivalent SPL, and got 3 going on. So you can't record. Can you?
What if you
Probably
turn off 4K?
For 1000, let's start with 1000. Stop. Maybe then 2000. I think 4000, yeah,
It's only on 4,000 now, right?
yeah, now only 4000 is going on. So you can't record at, what is this level?
4,000.
50.
50 dB you can't. You can try stop it now. You can just select single frequency. But we are just trying. Just select now 2000. You can't start now. We already started.
Why is it still going?
Okay, you can stop it. Let's you just play one frequency. Just
What was
4000.
that called again? When
Sure.
it's bouncing off of the
Acoustic radiation.
acoustic radiation.
Because bone conduction is driving at very high energy, you don't know what is the SPL in the ear canal.
Mm-hmm.
This is 4000 hertz. It's not starting right. So everything is getting rejected.
Mm-hmm.
Okay.
Then we try 1000. Okay.
This is still at 50, right?
50 at 1000, I think it's going recording. It's not rejected. Okay. Go to 55. 1000. It's 1000. So that's the loudest sound. Okay. Okay, you can do the 2K. You got a little bit time, just maybe 5 minutes will be done.
How does that change, like if you were to change the protocol to awake?
What's it?
If you change it to awake versus
It will go
sleeping?
to 40 hertz. The repetition rate going to be 40 hertz.
Mm,
40 hertz thresholds are better than, so that's another project.
like the amplitude will be larger.
Yeah. So historically people believe that 40 hertz
Is affected by sleep.
as affected by sleep. There was a previous student, she did like 40 hertz ASSR in her sleep, and the thresholds were better than 90 hertz.
Mm.
But the argument is that the 40 hertz is ASSR by different stages of sleep. The amplitude changes. So you can do a test retest reliability of 40 hertz. Normal hearing individuals do 40 hertz asleep. Do now.
Versus, awake.
Just do now, like then probably the same session. If you're done, just do one more time and just compare between sessions.
Yeah.
And if it is replicable, then it's telling you that, oh, 40 hertz, even though historically it's believed that you have to be awake, you can get reliable response when they're asleep. Just providing some evidence for that. Because they tested on infants with using 40 hertz, they reported better thresholds with 40 hertz.
Mhm.
Because 40 hertz larger amplitude,
Mhm.
better thresholds, that's known. But I think it's, people argue that it's affected by sleep. Is it still affected by sleep for this type stimulus paradigm? So that's the fourth project.